This is the video notes that go along with growth and decay word problems for exponential functions, and we're going to look at the decay problems today. So if I look, the difference in the formula for growth and decay is simply this, a subtraction, okay? Because decay means to decrease or to go down. Now, you talked about this in science when you talked about half-life and carbon dating. Okay, so since it is a decrease, we use the same formula. We just change the plus to a minus. Everything else stays exactly the same. Okay, so let's take a look at our first example right here. The original price of a car was $45,000. The value decreased at a rate of 12% per year. After 10 years, what is the value of the car? So I know that A is 45,000. Remember, that's your starting amount. My R is my percentage of increase or decrease. This time it's 12%. The decimal version of that is 0.12. And my T is the time period that I'm talking about, and that is 10 years. Now, whenever we do this, first thing we're going to do is write down our formula. A equals P times 1 minus R to the T power. Okay, so A is equal to 45,000 and 1 minus 0.12 to the 10th power. Okay, now you just go to your calculator and you can just type that in. And when you type this in, make sure you round it to the nearest penny because it is money. And what you're going to get is $12,532.54. So that brand new $45,000 car 10 years later is not worth less than $13,000. Okay, pause, copy that down, and then we'll go to example 2. Example 2, the population of Bulgaria has been decreasing at a rate of 1.3%. In 2000, the population was 7,797,000. Predict the population in 2020. So again, identifying our numbers. A, our principal, is 7,797,000. Our R is 1.3%. If you move that decimal 2 places, it's 0.013. And my T is going to be 20 because we're talking years 2000 to year 2020. So 20 years later. Now, let's write down our formula. A equals P parentheses 1 minus R close parentheses T. Substitute our numbers into the appropriate places. So 7,797,000 times 1 minus 0.013, all raised to the 20th power. Now, when you put that into your calculator, what you're going to get is 6,001,649 people. Okay, so the population decreased by over 1.5 million people in 20 years. Okay. Pause again and copy this down, and we'll go to number 3. Example 3, a new house initially cost $125,000. The house depreciated at a rate of 2% annually. What would the house be worth after 10 years? So again, my A, my principal, is $125,000. My R is 2% or 0.02. And my T is 10 because it's asking for the value of the house after 10 years. Now let's write down our formula. A equals P parentheses 1 minus R, all raised to the T power. So 125,000 times 1 minus 0.02 and that's raised to the 10th power. Now, again, this is money, so we're going to round our answer to the nearest penny or to the nearest 100th. So after we put in the calculator, we get $102,134.10. Okay. Now, let's go to example 4. You took 500, that is supposed to be a 0, not a lowercase I. You took 500 milligrams of a medicine. The amount of medicine in your system decreased by 10% every hour. How much will there be in your system after 8 hours? Okay, so how much medicine did we start with? We started with 500 milligrams. The rate that it's decreasing in our system is 10%, so that's 0.1. Our time now is 8. And again, our unit of time is different here because it's talking about hours and not years or days, but that's okay. The time unit is still 8. Okay, so A equals P 1 minus R to the T power. So 500, 1 minus 1 minus 0.1 raised to the 8th power. And when I put all that into my calculator, I'm going to have 215 milligrams of medicine left in my system. Now, please get these notes copied and put them into your interactive notebook, and you can go to Canvas and work on your assignment.